We'll go ahead and get started. Hello, everyone. Welcome to week 10 already. We're counting down the days and weeks. So we're going to go right into module 10. Before I get started, were there any nagging questions about the assignment or quiz for module 9? Everyone did pretty well, so I don't think there was any major faux pas in either. Subqueries can be confusing, but I think you're all getting the hang of this SQL nonsense, although it's very, very important. All right, let's get started. We're going to move in a little bit different direction. We're going to begin to speak about not just selecting data, but manipulating data. Hence, our next big journey is called data manipulation language, or DML. Another important part of SQL is just so. And why do we need this? Or what are we going to do? We're going to explain the importance of being able to alter data. Basically, we can look at it all day, but we should have the ability to alter data. And so I'm going to introduce the insert statement, construct and execute this statement, which will insert a single row using a values clause. And I'll show you what that means here in a second. Construct and execute insert statements that use unique values, null values, and date values. All are very important. And construct and execute insert statement that copy rows from one table to another using a subquery, since you know all about subqueries now. So you're going to learn how to manipulate data. So why do we need to do this? So up to now, you've been learning how to access data or select data or look at data or look at table structures. But now it's time to learn how to change the data. And changing the data is important. If you ever become a database administrator, a small portion of your job is creating the schema, but a big portion is changing and keeping up with all the changes that are necessary. So in business, databases are dynamic, and that is true, especially with how data is being used currently as a part of machine learning models, as a part of AI. It goes on and on and on. So yes, what you're learning now is essentially an important part of dealing with data. So there's their data is constantly in the process, or businesses are constantly in the process of having data inserted, updated, deleted. And believe it or not, those three basic methods of manipulating data are so important. I worked as a database administrator for a university, pretty large university, and I had some challenges, but it is still very prevalent to understand these particular concepts. So think how many times a school student's database changes from year to year. Yes, new students, student IDs, classes being added and dropped. This is all controlled by a database. Yes, including Chandler Gilbert. So we're going to learn all about how we can change data in a database. All right, so the insert statement, and it's just that. You're going to learn how to insert data into your table. So this is used to add a new row. It has three requirements. It requires the name of the table, and the name of the columns in the table to populate, and then the corresponding values for each column. And you can kind of start to visualize how that can occur. So how can we insert data? So how can we insert the data below in a copy of the departments table if we had it? So department ID, human resources, department name, manager ID, and location ID. We know that those are columns in that departments table. And we don't necessarily need to make a copy of it, but we're going to see how we're going to do that. We're basically going to use the actual departments table because our schema now is very fluid, and it's an instance that you use is an instance for you, and you're not going to impact anyone else. When I start teaching this course, yes, we had a common database that everyone used. Now we have cloud instances. But anyway, kind of a tangent, but a lot of these exercises will illustrate copying some of the tables don't worry about that. We can use the actual tables to insert and delete data. So the syntax here is what I want to point out. Insert into, those are the keywords of your insert clause. Into departments, that's your table name. And then all of your columns in that table, department ID, department name, manager ID, location ID. And then your values clause, you have to have corresponding values. So numbers should be numbers, dates should be dates, etc. Strings should be strings. Single quotes for your strings, no quotes for your numbers. And you see one-to-one correspondence here between the column names and the values of the data you're inserting. So we're inserting, as indicated in the slide before, 200 is the department ID, human resources is the department name, 205 is the manager ID number that will manage that department, and 1500 is the location. Okay, makes sense. Pretty straightforward. This statement is so important. As a matter of fact, a lot of the embedded code that you see out there, even now, you look very closely, whenever you're filling out a form or adding data, it's running some type of insert statement. All right, so another way to insert data into a table is to implicitly add, which means that basically you're going to add the data without actually listing the columns, but you have to remember some columns can be null, some cannot. So you have to make sure you match the required data to the columns that need data. If you don't, you get an error. And this is why I'm suggesting here, it's always good to describe your table. So that you know which columns require data to be inserted when you're running an insert. So to identify this whole, or to illustrate this implicit, basically we don't have to list the columns, but the values have to match data type and all that to the columns, to all the ones that require data to be inserted and cannot be null. So in the departments table, so we're adding another department. We're calling it a state management, right? Department ID is 210, the manager is 102, and the location is 1700. So that's referred to as implicit. You do have to be very careful if you're doing that. You need to know exactly, what the match between the values of the data and the columns. Does that make sense? Thumbs up so far? I know it's pretty early for a thumbs up, but I want to keep you going as we have a lot to cover. All right. So as I said before inserting data, it's always a good idea to check the columns, because sometimes you may be pretty sure that you have everything right as far as matching your values. And you see here, the department ID and the department name are not null, which means that whenever you're adding data, those two columns must obtain data. So when you're adding, if you're adding to this, you don't necessarily have to add the manager ID and location ID. And that makes sense because sometimes you don't know who the manager is going to be, et cetera, et cetera. But the department ID and department name. So remember that. So it is best practice to check your table. Check your table, and that describe statement will give you whether it's null, which is why that's been abbreviated so much, the type of data and whether it's null or not null. Very, very important. All right. So just to review a little bit about to continue the review, remember strings or characters are varchar 2, numbers are numbers, and dates are dates. Make sure you're matching because these new databases, you can actually get away with not matching, but yeah, and then you have dirty data and confusing data, et cetera. But make sure you're matching data types to data, numbers to numbers, date to date, strings to strings, et cetera. And also, there's some limitations here, some boundaries, like the number of characters, the size of the number, et cetera. You need to be aware of that as well. So the describe statement is very, very important. So to keep your data, exact and precise, you always want to consider basically how the columns are constructed. All right, so inserting rows with null values. Null values are a lot of fun. They can cause issues, but the insert statement need not specify every column. As I said before, if the column is nullable, meaning you don't have to insert data. Matter of fact, if you insert, like in that departments table, just a department ID, and what was the other? Department name, the other columns, and that row will be null automatically by default. We'll talk about that as well. And yes, I'm getting ahead of myself, but so in the employees, if you describe the employees table, and here's an example, I kind of jumped ahead of myself, but if you wanted to insert values in the employees table, you see here, we have employee ID, first name, last name, phone number, hire date, job ID, and salary. However, if you ran this query, you will receive an error because you're inserting data and you're not including some columns or a column that is a not null column, which is the email. And if you go back and describe, you'll see, well, we actually saw that before. If you go back to the employees table, you see that email says not null. So when you're inserting data in that employees table, these 5 columns they require data to be inserted. So that's why we get this error message, and it does actually tell you cannot insert null into student 1. That's the user, the table, and the column, right? Does that make sense to everyone? We all see that. We would all know what to do with that error message if we ran across that. It's a pretty easy fix. Just make sure you add an email column and email value. And this is what we do here. We added Polanski's email, and yay, we got 1 row inserted. All right. Oops. All right. There are special values that you can insert if there's a certain data type. Like I'm adding myself to the employees database, and I'm adding my hire date as today's date. So, and of course, this was back in February, but if you ran this query, and you can do it for yourself with all the required fields, I can add cis date, that's a special value, to this insert, and it will run successfully. And as you see, even though that's a date in February when I originally ran this, all the values are inserted correctly, including the ones that are null because we're not adding those to our insert state. Okay. You can insert specific date values. Remember, our default date format is day, day, month, 3-letter month, year, year. But the system will read it in any way that you want it to, but within the table itself, it'll default to this. So if you want to basically output, we've been through all this before, but what I'm illustrating here, if you want to insert a readable date per se, you'd have to identify that with the specific format. However, it's best practice, especially with dates, to stick with the default date format. You get less issues. Selecting data is one thing, inserting data is another. That's what I want to illustrate. Please stick with the kind of the default date value. This will give you less issues. Now, you see here, I'm converting a specific date to a format that I would like to insert. And you see here, I'm telling the system this is the format I'm inserting, but what the system will actually read into the column is that default value. So remember that. It's always, no matter how depending on how sophisticated or complicated you're going to make it, as far as the date, and all the dates that I've inserted have either been cis date or cis date with some type of iteration plus whatever, minus whatever, or the format. But if you feel like you need to do this, do some type of conversion, that's fine. You just need to make sure that when you look it up, do a select on that. It's going to read like this. It's not going to ever read like this, especially since you're selecting the format. Just remember that. That's just kind of a reminder of how the conversions work and all that. Generally, if you're doing any type of output, you want it to be more readable, but everyone's getting used to this but that's the global, kind of the global default anyway. It's always day, month, year. We've always kind of reversed that here in the US. It's always been month, day, year, but that's the acceptable default globally, just in case you were wondering. And yes, there was a time where we went to 4-digit year because of Y2K and all that, but now it's back to the general 2-digit year, et cetera, et cetera. And here's another example, and this is including a time. Remember, the default time is always, well, it's a long number, but you will see whenever you run a kind of any type of select, like here we have we like to display the 4-digit year, so we did a 2-char higher date, and this is just the select side, and then we inserted it this way, which you're only complicating it. I mean, that may be fine if you need to know the exact hour that the person was hired. I don't think that's necessary for the more, well, maybe there's a criminal investigation and yeah, where they hired at 5:20. Well, point being that generally you won't see a need to illustrate the time, but in case someone's asking, yes, the default time is midnight, basically 12:01 or 12 o'clock if you want to, because that's the first the start time of the day. But so, and we've gone through the conversions enough. And this is just a way to ensure when you're inserting the date, the special date or specific date correctly. My recommendation, you really don't need to do this unless it's required. Just stick with the default date, day, 2-digit date, 3-letter month, and 2-digit year, and you'll be fine. All right. All right. So that's kind of a quick lesson on specific formats, and dates are usually the ones that give you the most headaches. But as long as you just follow the general recommendation, you will be fine. All right. So we learned subqueries, so you can use subqueries to copy rows. So using an insert, and it's pretty cool. We're going to actually do that. Okay, in a geeky way, it's cool. But so each insert statement we have seen so far has only one row. So what if we want to create many rows or 100 rows, and we don't want to write 100 separate insert statements? You got it. We can use a subquery to do that. All the results from the subquery are inserted into the table, so we can copy 100 rows or 1,000 rows or 1,000,000 rows with only one insert statement. And you're like, woohoo! That probably makes a lot more sense. So if you take a look at this query here, or this example, we're building a new table. We're going to call it sales reps, and it's going to be populated with copies from the rows in the employees table. And in the where clause, we're going to be selecting those employees that have jobs like, rep. Basically, it's a like statement. So if you read through this, insert into sales reps, we built this table, right? ID, name, salary, commission percentage, and then select employee ID, last name, salary, commission percentage from employees, or job ID like percent rep. So yes, and this is the syntax. It's a little bit different, but it's basically a subquery. So you don't have to surround it by parentheses. You just add it right after the insert statement with the columns. And of course, the columns have to match ID, name. See, these are the new columns: ID, name, salary, commission percentage, employee ID, last name, salary, commission percentage. As long as you do that, then this query will run quite nicely, and we'll be able to copy all the sales reps right into this new sales rep employees table. All right. So the number of columns and their data types, yeah, I just said that. Make sure they're matching, the number of columns match, the data type match. That's very important. If you look at that syntax, pretty straightforward, pretty direct as far as how the data is, and it'll copy multiple rows into your correct table. So if you if you run this, of course, we haven't built the sales rep table, then you would see that both tables will have the appropriate information. But now we have a subtable. So the one thing I do want to mention in this subquery scenario, you're not deleting or removing anything from the employees table. You're just copying that information to the sales rep table. Does someone have a question? Do you have a question, Diana, or did I just?
No, that was an accident.
Oh, okay. I saw your name pop up. All right, let's continue. But before we continue, does that make sense, the whole subquery? Let me go back to that syntax, because sometimes that looks a little different, but this is the way that you syntactically write this. Insert into your columns and then select employee, right? Just like that. Does not have to be any different. Of course, you can have your subquery could be any type of query, but all of that data is going to be added to this new sales rep table. All right, does that make sense? Questions, comments? Makes sense? You can do that in your sleep. All right. So our terminology, yes, we're talking about DML, which is basically, think of the M as manipulation, which is different than DDL, which is just data, and then insert, and then values. And DML is several clauses, but insert is one that we're going to cover this evening. All right, and that's our summary. And we're going to move right into update. So now we learned how to insert data. So what do we have to do to update data? That's our next topic. So we're going to construct and execute an update statement. We're going to go right into the delete statement, and I always have to tell you my story about both the update and delete situations that I created. And this is at a university with 35,000 students and 6,000 employees and thousands of staff. Anyway, construct and execute a query that uses a subquery to update and delete, so you can kind of get an idea of how that would look. And then even using correlated subqueries to update and delete. Very powerful stuff on the DML side that you have to be very careful of. And I will give you some very distinct warnings about running updates and deletes. We're going to talk about explaining. I'm going to explain to you how foreign key and primary key integrity constraints affect update and delete, which means that the referential integrity, meaning how the tables are connected to each other. You can't simply update things without considering that connection, or that how the primary key foreign key works. And then the last thing I'll do is explain the for update clause in the select statement. And this is just a way to control data before it's manipulated. But it is useful, especially in a shared database space where you probably have a lot of users. And we'll talk about that. All right, so wouldn't it be wonderful? Would it be a wonderful world once you got something done? That's a dumb question, but we'll go with it. It never needed to be changed or redone. We all know, we're all adults. We all know that rarely happens. So your bed will be stay made, your clothes will stay clean and ironed. You always get passing grades. Well, you're all going to get passing grades because you're all good students, so we're not worried about that. But unfortunately, in databases, as in life, there's nothing permanent except change. Very cliched statement, but it is true. So updating, inserting, deleting, and managing data, yes. As a former DBA, actually that got to be so mundane because I would have to basically by myself run all these updates and inserts and even deletes before. And this was unfortunately, before a lot of the automation, before a lot of the front end and blah, blah, blah. So, but all that aside, we're going to learn, well, we're going to become DBAs here. And as I said before, this was probably about 75% of my job was these DML statements. All right. So the update statement, this is basically used to modify existing rows, and it requires 4 values, the table, right? The name of the column or columns that are going to be modified, the new value of the column, and a condition that identifies which rows in the table. That last bullet point is so important. So I have to pause and tell you my story. This is a true story. So I was working as a DBA at a university, and I was in charge of running, at least verifying all the processes throughout the university, including payroll. So there was an instance where there was a pretty substantial raise that went to a group of employees, not all employees, just a specific group. And so, and back then, this is long enough ago, where the proposal or the request would go through kind of a form, and basically I would create the query or check the query and then run it to the database. Well, this particular instance, only a portion of the employees were supposed to get raises. Of course, I forgot my where clause. So all employees got a substantial raise. And yes, and after that occurred, I was going to do kind of an update or a flashback, and I was told, nope, can't do that, blah, blah, blah. So there's a lot of people that were happy. The university was not so happy. So that's my update story, and that's a true story. It actually occurred. Of course, I gave myself a raise too, which I was not supposed to. It was pretty funny. So update is pretty powerful, and I have a delete story too, but I had to restore that particular one. So yes, the update is something that you really need to pay attention to, and generally you never want to run either of these, an update or delete, without a where clause. Because remember, your where is pointing to a specific condition. And so here's an example on our employees table. So we're updating a phone number. So update employees. Here's the syntax: set phone number, which is your column, equal to, and we have a phone number where employee ID is 303. All right. So that's going to take Angela Wright and change her phone number to that phone number, which is an Arizona number, 223-1234. And this is what we will see. Whatever her value was before, we won't see that unless we do a rollback or something like that. Update column set. Update table, update table. Yep. Set column equal to new value, and then the condition. Remember that particular order. And we can change several columns or several rows, and that an update statement really depends on essentially what we have in our set of column values. So update employees, set phone number equal to this, last name equal to this, or employee ID is greater than or equal to 303. So that's going to be several employees, right? So maybe we didn't want to do that. So what I did, because I added myself to that employees database, and I was employee 304, whatever, I don't remember. But now I changed my last name to Jones and my phone number to that phone number. So once again, you do need to be very careful. I'm pretty sure that it's not going to be correct, but that's how powerful this particular update statement can be. Things like greater than equal to, yes. Probably want to be a little bit more explicit to who's getting updated. All right. And if we ran something like this, so this is just an illustration. We changed everyone's last name to Jones and changed all of their phone numbers to 654321. Yeah, another example where, yes, please be careful. Yeah, make sure you have exactly what you want. And once again, don't try not to ever run an update without a where clause or delete, because it can do some strange things. All right, updating a column with a value from a subquery. Yes, you can run subqueries just like in the select statement with your update statement. And if you look through this syntax here, update employee, set salary equal to, and then select salary from employees where employee ID. So we're basically giving everyone the same salary as employee 101. Does everyone see that example there? The subquery. Yep, makes sense. And in this case, the subquery is specifically surrounded by parentheses because it's update and then your subquery, which this value is just going to be a single value from this, right? And then all of the employees, once again, that have employee IDs that are greater than 3 or equal to 303. Will you ever run something like that? Possibly, but once again, you have to be very careful with your update query. So all that I'm saying here, and yes, you can do a lot with subqueries. You can use 2 subqueries. You can use several subqueries for columns. And this is just another way to consider this. Just be very careful that you know exactly what part of your record or what part of your database is being updated. I would be, once again, you can make a, pretty substantial mistake by not paying a whole lot of attention. But here's this 2 subquery example. Update employees, set salary equal to that select salary from employees where employee ID is 205. So we're basically going to set, this is a kind of a difficult way to do it, make sure that if we read through this, the salary of employee ID 205 and the job ID, employee ID 205 to employee ID 206. So basically, employee ID 206 is going to have the same job as employee ID 205. And that's a difficult way to read through that, but that's a way, and you can do that if you wanted to use subqueries in your update statement and not have to look at the specific values, which is the whole idea of subqueries. You can do it that way. So, and in this case, William got promoted to assistant or accounting manager. So he's going to be the same position as Shelley Higgins. So there you go. You did that with 1 query. Does that make sense to everyone? Thumbs up. All right. So subqueries continue to be useful. All right. Updating using correlated subqueries, kind of the same idea. So in this example, a copy of the department name column was created in the employees table, often happens. The data from the original department table was retrieved, copied, and used to populate the copy of the column it's a lot to do, but basically we're running an alter, we're adding a department name right in an employees table. And that's what an alter is another, did we talk about DCL? Anyway, this is a way to actually change the structure of the table. So we're adding just a department name, and then you get the message, and then we're just updating it, setting that department name in the employees table to the department name that's in the department table. So that's why it's called a correlated subquery. You're just copying all the departments from one table to the next. Do you really need to do this? Generally, if you set up the database the way it's set up, you probably, unless you're doing some type of merger or something like that, but that's, and I'm not sure. I got Shelley and William down here again. Oh, we're just selecting first name because that's the accounting. We're just displaying that department all from the employee table. So yes, so that's called a correlated subquery because we're correlating data in one table from the data in another table. Is that necessary in our small database scenario? Yeah, you can illustrate that, and it's not really that necessary, but in a larger schema, you probably want to run something like that. Okay. Does that make sense to everyone? Always have to check for understanding, or just to see if everyone's still awake. Okay, that's good. All right, now I guess the mens rea, the coup de grace, or the bane of the database existence. That's just, well, it used to be. It's not so much anymore because you can roll back or restore easy enough. But the delete statement, another story. Of course, this one I was able to resolve right away, but I was deleting or actually I was just updating a department. I ended up deleting them. And so don't ask me how I did that, but the delete statement is another one of these DML statements. And basically you can remove, and with the Oracle system, when you run a delete statement, you're not actually removing it completely. It actually goes into a dormant role. So don't worry if you delete something inadvertently, because it's very easy to restore or do a rollback, and we'll talk about that later. All right, so the delete statement requires two values, the name of the table and the condition. Once again, the condition that identifies the rule to be deleted. Please never, ever, ever, ever run a delete statement without a where clause. That's one of the general rules of thumb. If you don't include the where clause, then you're removing the whole, basically deleting the whole table, deleting the whole schema. And yes, subqueries are very useful in deletes. But you have to be aware of a few things. So there are constraints that will come into play when you're trying to delete something, because there's this whole thing of cascading and all these values that are connected. But you see here in this example, we're trying to delete using a subquery the department ID from departments where department name is shipping, and we're getting an error because we're violating a primary key foreign key integrity. So if you get this error, you really have to pay attention to what the relationship is between those entities in your table. So delete is well, you have to be very, very careful. All right. So here's another example. And I'm using a copy of the employees table. So well, I want to delete all the employees who work for a manager that manages less than 2 employees using a subquery. So delete from copy of employees where manager ID in, and then select manager. So that's going to be a group of manager IDs, right? Having count department less than 2. And basically it's just going to return, and this should not be a big mystery to you as far as how you can run this query, and it's relatively safe because it's only going to look at departments with less than 2 employees, as the description states. All right, integrity constraint errors, and you normally will get that. This is the protection around your data in your database. The reason why, as a DBA, you create these relationships, and with these relationships, you develop specific integrity constraints automatically. And so whenever you're running a DML, there's all the system will automatically check to make sure you're not breaking any of these rules. So, and if any of the rules are broken, then basically you get an error, and that's just the way you maintain the integrity of your data across these tables. In which, if you look way back in the beginning, the whole idea of creating a relational table or relational database is so that you don't have one big table with tons of data. You have all these relationships, primary key, foreign key. And yes, that's kind of a review, but that's the whole idea of integrity constraints. So here's some examples that where constraints are violated. Here's a not null. You know what the not null constraint? Basically, you can't update or insert or update a value of null into these not null, which is basically a constraint. And constraint means that no, you're breaking the rules. Oh, I can't do that. So if you read through this query, update employee set last name equal to select last name from employees or employee ID. So this one's easy. There's no employee ID 999. And this is the error message that you'll get. You know, it's just basically you're trying to do something where you're getting null from this. So it's returning null from this subquery, which you can't put a null in last name. Constraint, it's screaming at you. Don't do that. You can't do it. All right. All right. Also, and I've alluded to this several times, there is a relationship, and generally there's columns that are named the same for a specific reason. For example, you have department ID and employees table and the departments table. And that way you can always map a department to an employee. That's the specific reason for that. So you never want to delete a department or delete an employee from a department. You have to make sure not to violate these constraints. And these little things you'll wonder, well, how do I do that? But we're going to talk about that later, specific ways that you can check that and not violate constraints and still keep your database and your data clean. All right, little test here. Which of the following statements will return an error? Please read through those and either type your response in the chat, or you can unmute and yell them out, get you all to talk a little bit. So which 1, 2, or 3, which will return an error? Which will run? Based on the very basic lesson of constraints that I just issued or just conveyed to you. Or you can volunteer a rep from the group. Who's going to speak for the class? Who's going to be brave enough? Let's see, no one's typing in the chat. You're all going to be silent, huh? Someone has to say something. We're supposed to be an interactive group. I'm gonna bring up my Jeopardy music, and we'll just sit here and listen to the Jeopardy theme until someone says something. Are we all still out there? Hello? Does this thing work? So which will return an error? Oh, someone typed in the chat. Yay. Carmel says 1. 1 will return an error. Anyone else in agreement? So 1 says update employees, set department ID equal to 15 where employee ID is equal to 100. So we can't do that, right? Set department ID equal to 15 where employee ID is equal to 100. That's the only one we're going to delete from departments where department ID is equal to 10. I think number 2 to me is problematic. Update employee, set department ID equal to 10 where department ID is equal to 20. Those all seem kind of suspicious. All right, since no one's responding, let's see what the magical system says. Oh, where'd it go? Where did my... All right, hold on. All right, so number 1 will return an error because department ID 15 doesn't exist. So if you look at the... All right. Since no one wants to volunteer the responses, let's take a look at these. So I'm going to take the time to type in these queries: update employees, set department ID equal to 15, where I guess I could have done this ahead of time. Employee ID is equal to 100. So if you run this, oops, of course my work. SQL developer went to sleep. This is giving us a constraint error, right? Integrity constraint, parent key not found. So that one, so Arminol is right, that one's not going to work. Let's run this next one. Delete from departments where department ID is equal to 10. Oh, that will run, no problem, right? See what this says. No. Yes. Another issue. Integrity constraint error. Yeah, you're violating the constraint. So 1 and 2, you can't run those unless you. All right, the last one, update employees, set department ID equal to 10, where department, that sounds very awkward. Department ID equals 20. So we're changing everyone from a department 10 to department 20. That shouldn't be a problem, right? Let's see. Oh, that one updated. So in case you were wondering, so now this one and 2, yes, 3 actually will run. As long as that exists and you're not violating a integrity constraint, although we did change all of the department 20 folks to department 10. But all right, I just wanted to show you that. So, all right, so be aware of integrity constraints. You'll get to run several examples, but that's usually an error of something that you have to account for before you can make any DML changes. All right, one other clause I want to point out to you, or another clause I want to point out to you, is the for update clause. So when a select statement is issued against a database table, there are no locks, or no locks are issued in the database. In other words, which means that it's wide open, and if someone else is, if you're sharing the database, you do. It's just depending upon the timing, but you can help with that. So most of the time, this is how you want the database to behave, no locks, and just make your changes or select your data accordingly. But sometimes you want to make sure no one else can update or delete records while you're selecting it. That's what you would use the for update clause for. As soon as your query is executed, the database will automatically issue exclusive row level locks when all rows returned by your select statement, which will be held until you issue a commit or rollback command. So basically it locks your rows until you issue these following commands. And here's the syntax for the for update. And yes, I did type it wrong. It's not the number 4, it's the word for. Hopefully you didn't pay much attention to that. I was going to change that, I forgot. But anyway, for update. So you have a select statement here with your where clause. Right after the where clause, you put a for update, which locks everything that's associated, all the records that are associated with that select statement, which is basically this result, until you commit, until you run a commit. You actually have to run a commit. Although with the SQL developer, an auto commit is always ran. So that those seconds or so that you're running the query, yeah, it's not a big deal unless you have thousands of users, that have access to run queries on your database. So it's just locking the rows, so you have clean data all the time. That's your for update. So these 4 rows are now locked by the user, etc. Not a big deal so much in the evolution of database access with the cloud databases and instances that are constantly being checked and updated, and the automation is high end, et cetera, et cetera. But in the olden days, yes, this was very important, because if you don't lock, then someone's trying to access data or change data at the same time you're trying to select it, and your results may not be clean. All right. So here are key terms in this long DML section: delete and update, integrity constraints, correlated subquery update, correlated subquery delete, and then your for update. That's a lot, but those are very, very important aspects of DML. All right, our next topic, we're going to look at default values, merge, and then multi-table inserts. And so here are objectives, default value, merge, DML statements using subqueries. We already did that, but we're going to repeat it, and then multi-table inserts. So up to now, we've been updating, single insert statements. It's been relatively easy when adding records one at a time. What if you want to add multiple records? We saw some of that, but and what if you have multiple sources to add multiple records? In essence, what you want to make sure, whatever you need to do, if you're in a DBA situation, especially with the speed of databases now, there's really no need to clump a lot of this together. It's probably best to be very careful with data without being so expedient that you're making mistakes. So how do you determine what has been newly inserted or what has been recently changed? So in this lesson, we're going to basically look at a more efficient way to update and insert data using sequence of conditional insert. It's a way to organize if you have several points of data to insert. So as you extend your knowledge, probably will appreciate more effective ways, which is we're trying to get you into the habit of learning how to query more effectively. So in this scenario, in the event that a new row is inserted and no value for the column is assigned, the default value will be assigned instead of a null value. So the whole idea of a default, and when you set your table up, if you remember way back when we were creating tables, you can actually create a default for your value there. But that's probably the best way, like sysdate and things like that, or user. Special values like that really help if you add those as default values, so you're not inserting the same or the special values all the time. That's the reason for it. So if we're creating a new table called My Employees, you see here that our hire date is always going to default to the sysdate. Remember, the sysdate is the current date. Whenever I created an employees table, and I've done a lot of these, it's always been sysdate. It's the easiest way to ensure. So when that employee is added to into the table, the sysdate is automatically added. Becomes a default value. Okay. And so here's an example that I used back in February. So insert into My Employees, hire date, first name, last name, and we know that the default. So all we need to do is indicate the keyword default, and it knows that the default is sysdate. Or you can actually put sysdate there too, but so either or. But here we know that our default is always going to be the sysdate. And as you see, I added Angela, and then I added myself, and I only had to do first name, last name. Efficient. Does that make sense to everyone? That insert scenario and the keyword, the default, how defaults use. Right. Okay. All right. Let's continue. Explicit defaults can be used in your insert and update. As we saw before, update my employee set hire date equals default. The default for the employees table is sys date. So you explicitly updating it with the default. All right. All right, and that's default. Default, and primarily I've used default a lot, but mostly it's for date. Or if you want to default in another way, you can always default whatever field you like. Okay. All right, let's move to the merge command, or the merge statement. The merge statement accomplishes two tasks at the same time. So you use the merge if you want to insert and or delete simultaneously. And you're like, wait, how do you do that? So basically the merge will check to see if there's a value that exists, and then it will update. If the value is not, it will insert. And yes, it'll do that simultaneously with one statement. All right, and I've talked about privileges and all that. So take a look at the syntax here. Merge into destination table using source table on a matching condition, usually some type of identifier key when match. So a matching condition, and you'll see what I mean there. When match, then update, set, and you set, remember, update and set the values. When not matched, then insert. And then so you're either updating the values or inserting a value or values. It's a lot harder to explain, much easier when you see the example. So we're going to create a table, and you can do this or not do it. I think I just did this. And we're basically going to copy our employees table. So creating a table, copy employees and remember, you can do this. You're copying all of the employees, all 20 of them, into this, and their columns into this new table. So when I select from it, I get, actually this one, I'm only copying all the employees that are in department ID greater than 100. So that only copied 2 employees, Shelley Higgins and William Gates, or Geitz. Right, so that's the records that are in my copy employee table, right? So then I'm going to update this table, set last name equal to Cotton, where employee ID is 205. So Shelley Higgins just got married. So now her last name is going to be Cotton. So in our copy employees table, just, I don't think I did run a select, so it's going to be Shelley Cotton and William Geitz. All right. So now we have these 2 tables, right? Copy employees and employees. So merge into copy employees and as an alias using employees, right? On employee ID or employee ID. So we're correlating the employee IDs. So when they match, then you update, set last name equal to last name. So when the employee IDs match, we're going to set the last name equal to whatever last name in the copy employees table to whatever the last name. So remember, we changed one of the last names, right? So Shelley Higgins' last name, we changed to Cotton. And then we're going to set the department ID equal to the department ID. So we're merging, remember, the copy employees and those 2 employees. And so when it's not matched, then basically we're going to create a new record in the copy employees table. So basically, to read through this, interpret this, so we're going to use the whole employees table. We're going to merge it into the copy employees table. So if everything matches, it's just going to update, the last name and the department ID. If it doesn't match, it's just going to copy everything, right? We're just going to do an insert. So what happens, we get our 20 employees again, But you see, Shelley Higgins is back to Shelley Higgins because she was Shelley Higgins in the employees table. We changed her name to Cotton, but now, and this is the copy employees table that we're looking at, just to let you know. So it copied all employees from the employees table to the copy employees, but now Shelley Cotton is now back to Shelley Higgins. Does that make sense to everyone? And you can run this if you want to see that this makes sense. So we're looking, I should add, this is select star from copy employee. Did I add that? Oh, yeah. So yes, it's a good way to kind of to do, if you want to make sure, everything is all right. So that's merge. And then I dropped the table just. So I did all of this just to make sure you saw that, because if you go back here, we changed Shelley's name, although I should do a select star from copy employee, so that you see that her name is now Cotton in this copy employee table. And I run the merge and I get that. All right, and you all gave me a thumbs up. So I provide another example, but that does give you the gist of how the merge works. And if you're thinking about lots of data, it can be very useful. All right, new topic. Multi-table inserts are used when the same source data should be inserted into more than one target table. It's useful when you're working in a data warehouse. So data warehouses are huge amounts of data, but you probably want to consolidate it or manage it in a way that you can work with just a few rows at a time. So if you ever get into the opportunity to see what a data well, everything is a data warehouse now, with all these huge data sources for AI and all that. You're talking about terabytes of data, multiple terabytes, just a ton of data. So an example, imagine if we had we do have telephone data records. We don't have telephone books anymore. So then add to that your internet surfing and downloads and ringtones and all the data that's out there for mobile apps. Multiply the number by the total number of customers, so thousands and thousands. So we're illustrating a ton of data. So multi-table inserts can be unconditional or conditional. So we're talking about inserts. In an unconditional multi-table Oracle insert, all rows returned by a subquery. In a conditional, you can specify either all or first, which means the first. So we're dealing with tons of data now. So if you're in a multi-table insert scenario, if you want to specify all, the default value, the database evaluates each when clause, regardless of the result of the eval. So it's going to evaluate all of the, when you have when, if, and when. And I think I do have an example here. Let's see. Yes. When you specify first, the database evaluates each when clause in the order which it appears in the statement. For the first when clause that evaluates to true, the database executes the corresponding into. And this is kind of jumping back to when we talked about when and into, but I'll give you an example here, which will probably make more sense. And please run through the examples in the practice queries. So when we're running a multiple table insert, this is what the syntax looks like. Insert all into clause values clause subquery. So insert all into my employees values hire date first name last name, right? And then that's one table. Into copy of my employees, that's two tables, hire date first name last name. Select hire date first name last name from employees. So we're inserting all this, and you can use as many tables as you like here. And this seems very straightforward, but if you're dealing with tons of data, like in a data warehouse, this would make your life make it much easier to manage. So in essence, to explain that, it will receive all the rows from the employees and insert them all in these two new tables, just in a simple insert all. And here's that kind of example. Insert all into copy of employees, employee ID, first name, last name, email, phone number, hire date, job ID, salary, and values. And we're inserting those values into copy of employees. So this is a very basic example, but I mean, if you use a subquery and things like that, you can see where you can do a lot of inserts with one kind of multi-table insert query. And here's one that I pulled not from our database, but one that was actually used from a mobile service provider that was moving talk and text and pick from one. This is truly an example that was run. I don't know if it was Verizon or T-Mobile, one that they were using to pull data and insert across certain requirements. You see here is all calls, public record calls, short calls, long calls, and there's conditions, and so make sure you can read through this. You don't well, obviously you can't run this in our database, but this is what you would see, and I'm pretty sure well, I'm very comfortable that you can read through this and understand what's happening with this. And you have to remember there's millions of records here being moved. And this is truly representative of a multi-table insert. But they're just creating all these little tables, all calls, public record calls, short calls, and long calls from the major data warehouse holding all the call information. So this is a kind of a real life conditional multi-table insert. Does that make sense to everyone? I know that's dumping a lot on you, but you could probably read through this and really, oh, I see how that works. And have certain conditional identifiers for talk, text, and pick and all that. So, all right. Got enough thumbs up there. I just found that like last semester. A gentleman, I forget which service provider, actually, he says, this is one of our basic queries that we run to identify. Anyway, so this stuff is real. What you're learning is really what you'll see. Yeah, you probably think, yeah, I'm never going to see this. And if I look at or work with a DBA and Verizon or T-Mobile, yes, you will see it. Believe it or not. All right. Our terminology here for this topic: default merge, multi-table inserts, all first, and else, when, and then. Okay, that was a lot, I know, but we got through it. So what I'd like to show you now, what we're faced with for module 10. A couple things here that are a little different. Our lecture will go there. There is an extra credit opportunity this week. It's like a quiz. There's 23 questions in here. You don't have to do it. If you do it, these are 23 plus points. It's an extra credit opportunity quiz. And you can do as many or as little as you want. It's all plus points. It does not count against you if you do not do any. But if you need extra credit, please go through that. And it's basically questions that you've seen here in the last, well, I don't remember what I put in there, but let's see. Write a query to create a result list from employee table that includes the first initial, things like that. Things that you've seen before. And most of it is just writing queries. It's basically a way for you to kind of enhance, and yes, you probably get tired of it after like 3 or 4, but That's all extra credit points. Remember, extra credit points. So if you want to get in some extra points, please go for the extra credit quiz. All right. Okay, and then we have our normal resources. I have some database commands. If you remember DDL, did we go over DDL? Basically, how to impact your entities, tables, your DML, select, insert. Actually, select is part of DML. Your DCL, we haven't really gone over privileges. We'll hit that a little bit. Your transaction, commit, save point, rollback. But yes, make a note of these. These categories of SQL will be a part of the final. You just need to know where they are located, how they're grouped together. All right. Yes, Diana.
So when we do the homework assignment and whatnot, is it going to change our tables and permanently change them?
So it'll change your table, but it won't impact unless I recommend that you change the tables. It's not a big deal to change. So yes, to answer your question, yes, it will change your table. And remember, you have an instance that doesn't impact anyone else's. So you can do
Okay.
whatever you want with your schema.
Could we reset our instance to get back to the original tables or
Yes.
okay, cool.
You can go back to the original query. Remember that way back? No, actually, you didn't have to run that. So if you go way back to module 1, or I have to make sure I have that query it's still in there. But I mean, it will not. Well, unless you do something really weird, like deleting your whole table. You can always do a rollback. Remember, you can roll back to any point. And we're going to go over that if you're uncomfortable with that. But yeah, I think for this semester, I didn't have you all did not have to run a query to create your tables. But since you said that, let me check something right quick. Let's see. All right. Yeah, I took that original query out. So if you want the schema yeah, we didn't want you all to run that because there's some issues with it. But if you want to return your query back to its original state after you've run some of these DML, just let me know. I'll give you the original query to it. But it's really not a big deal. Even if you change things, unless you delete the whole schema, which you're not going to do that, right, Diana?
I don't know. I'm learning. I might accidentally.
Okay, well, so be secure that it's pretty easy to restore it, but if you do that, then yes, you'll be all right. It won't be it won't be a disaster. All right, extra credit, database commands. We have some resource videos which are pretty good. Basically on DML, insert, update, delete. Please watch those multi-table inserts. That's actually one that's a part of a lesson that comes from Oracle, and I would suggest going through this to help you learn about multi-table inserts, because I went through that pretty rapidly. Remember, these resources are all there for you, all right? And then your practice queries. And there's a lot of DML and there's DDL, DML. Yeah, and it is possible you may alter your schema. I think this is probably where I'm. So not just for Diana, if you're afraid that your database is far too different, but that's actually a good thing. When you run through these assignments, and if I see that your data is coming back a little bit different, that tells me that you're at least running the queries. But it really depends on the results. But so don't be concerned about that. We can always, it's very easy to restore the database. As a matter of fact, if for some reason you think your database has changed a lot, I can go in and restore it in like a couple seconds because I have that query running on my instance and I can get into all of your. Anyway, so practice, practice, practice. You're still learning. That is okay. Just don't delete the whole database. Now you can delete the whole database, but I'll be able to restore it. All right, and then your practice exercises. Once again, as usual, all very useful. All women will change your database some, but nothing too nothing like a catastrophe or anything like that. So please, no panicking allowed. Please go through these. I think you're all doing pretty good from what I can tell, because I can see the results in your assignments. Drop table. Yeah. Well, you can drop table. You can even, like I said, you can delete table. You don't delete it, but be very careful with, well, drop and delete. So there's some discussion about. No worries. This is a learning environment. It's okay if you delete the whole schema. Just don't hack into the server and delete all the instances. That might be fun. We don't want you to do that. All right, and then we have an assignment as normal. This one's only 6 questions. Dealing with Homer Simpson. Yes, you can add Homer Simpson to your, he was just hired, so you have to add him to your database. And then the quiz. And that's it. I think that's it. Only one quiz, yep. All right, and that's it for this week. Now, let's see. I did want to, we are planning to meet Monday of Thanksgiving week. I don't see that we really cannot meet that week because we are going to go into DDL next week. We're going into views, but we're getting very close to the end because, oh, that's what I wanted to propose. We have module 11 next week and then module 12 Thanksgiving week. 13, 14, and then we're in the final week. I don't know if I counted for that. Yes, we are meeting on the 23rd because that's a huge, DDL is huge next week. As a matter of fact, that's 2 sections compressed into 1. So I was going to try and get away with 3, but that's too much. So I'm only talking out loud to state that we will meet the 23rd, which is the week of Thanksgiving. It's a light week. That's module 12. The 23rd or 24th. Oh, it's the 24th. All right. So next week, the 17th. But it's kind of a regular week. Next week is kind of a heavy week. I did want to warn you of that because I had to compress all those DDLs and constraints into 1 lesson. So prepare yourself for that, but you'll be able to make it. And then Thanksgiving week is pretty light. And then basically only 1 more week. A very, very light week for the week after Thanksgiving, or 2 more weeks. And then we get into the final week. So you see, we're counting down to the end. So hopefully you're all still surviving. That's the key here. So a couple more in the chat. No, don't drop database. No, don't do that. That's, although you still can recover it, but so is that Trevor? Yeah, no dropping databases. All right, any Any comments or concerns about module 10, DML? Okay, then. Well, that's a wrap for this evening. I hope you all are doing okay. I will see you all next week. Correct?
Thanks. See you next week.
All right. Take care.